Hello students, in this video we are discussing a gate numerical. See the next problem, asking the gate examination of 2016 for 1 mark. Consider a binary data transmission at a rate of 56 kbps using baseband binary PAM system, pulse amplitude modulation, that is designed to have raised cosine spectrum. Very good. The transmission bandwidth in kilohertz required of a roll-off factor of 0.25 is. Here, what is the difference in the PAM comes to PCM is, I given the table also, see. In PAM directly we are sending the samples, but in PCM we are encoding and sending. So in PAM bandwidth is RB, but in PCM RB by 2. Bandwidth or minimum transmission bandwidth. If it is given raised cosine pulse, in the both cases replace RB by 2 into 1 plus alpha. Here the given is PAM raised cosine pulse. So what is the bandwidth? Is RB by 2 into 1 plus alpha. What is RB value given? 56k by 2 into 1 plus alpha is 1 by 4 or 0.25. Then it will be 5 by 4 na? Are you getting my point? 5 by 4, 4 2s are 8, 8 7, 7 5s are 35. It is in kilohertz, already in kilo he mentioned, so you need to type 35. If it is same problem given in the PCM, then half of it will come, 35 by 2 will come. So if it is a PAM, directly samples we are sending RB. In PCM encoding we are sending RB by 2. If they mention raised cosine pulse, replace RB by 2 into 1 plus alpha. See the next problem. This is asking the 16 gate for 2 marks on the matched filter. So what is the given problem? An analog pulse S of t is transmitted over an AWGN channel. The received signal R of t equal to S of t plus N of t, where N of t is a additive white Gaussian noise with a power spectral density of N0 by 2. The received signal is passed through a filter whose impulse response is h of t. Impulse response is h of t. Let Es and Eh denotes the energies of the pulses S of t and the filter h of t respectively. When SNR is maximized at the output of the filter, SNR max that is, which of the following is holds? Option A, Es equal to Eh. SNR max is 2S by N0. Option B, Es equal to Eh. SNR max is Es by 2N0. Option C, Es greater than Eh. SNR max greater than 2 Es by N0. Option D, Es less than Eh. SNR max is 2 Eh by N0. After reading the question, what we understand? SNR is maximized means it is nothing but a matched filter. What is the impulse response of a matched filter? The same input, but a capital T minus small t, where capital T is a duration. Even if you make a time reversal or time shifting operations also, no change in energy or power. So the energy of Es and Eh both will be same. Means option A or maybe B. And we already know, if you are using the matched filter, noise power is maximized to N0 by 2. So calculate S by N max. Signal is Es, N value maximized to N0 by 2. So 2 Es by N0. Can see the options? A simple problem, but they given a lengthier things. You need to understand it is a matched filter because SNR is maximized. Then if you solve, option A will come. Simple question for 2 marks in the 16 gate. Clear? Yeah. See the next problem. An ideal band pass channel 500H to 2000H is deployed for communication. A modem is designed to transmit bits at the rate of 4800 bits per second using 16 QAM. The roll-off factor of a pulse with raised cosine spectrum that utilizes entire frequency band is Means what is asking? What is the role of factor value? This question is asking in the 2016 GATE examination for 2 marks. So here, what is the formula for bandwidth? The bandwidth formula is, he given a MLA signaling scheme. So 2 by NTB. That is 2 RB by N. And here 16 QAM means M value 16. Then what is N value? M equal to 2 power N. M equal to 2 power N. This is 16. So N value 4. So this is 2 by 4. And he is using raised cosine pulse. So replace RB by 2 into 1 plus alpha. What is the bandwidth? See, where to where we are using 500 to 2000. Highest minus lowest. So 1500 equal to 2 cancelled. RB value given 4800 by 4. 4800 by 4 into 1 plus alpha. We need to calculate that alpha, role of factor value. And 4 ones, 1200. So 1 plus alpha equal to 1500 by 1200. So 3534. So 5 by 4. Then what is alpha equal to? 5 by 4 minus 1. So 1 by 4. 1 by 4 means 0.25. So in the fill in the blanks, you need to write 0.25. See, the questions from the role of factor, raised cosine pulse, no inter-symbol interference, MRA signal scheme bandwidth, the common problems in digital communication. Simple question for 2 marks. See the next problem. A speech signal is sampled at 8 kilo and encoded into PCM format using 8 bits. The PCM data is transmitted, this is important point. PCM data is transmitted through a baseband channel via 4-level PAM system. The minimum bandwidth in kilohertz required for transmission is. This problem asking in the 16 GATE examination for 1 mark. Simple problem only. Here, what is the RB? RB value is students NFS. N value is 8 and FS value is 8K given. So 64K or kbps. This is transmitted through what? 4-level PAM system. So 4-level means simply bandwidth equal to RB by 4. 4-level PA system, RB by M or 4. M is here 4. That is 64K by 4. I can say 60 kbps. That is the answer. If we say 8 level means by 8 you can write. 2 level means by 2 you can write. See the next problem. A binary baseband digital communication system employs the signal P of t equal to 1 divided by root ts. 0 is less than or equal to t less than ts. 0 otherwise. For the transmission of bits we are using. The graphical representation of the matched filter output y of t for this signal will be. What is the output of any system, students? Output of any system y of t equal to input convolution with the impulse response. Here logic is impulse response equal to p of capital Ts minus t, where capital Ts is the duration of the input, p of t is the input. Now what is this? This is given a rectangular pulse. See, where to where sir rectangular pulse? 0 to ts sir. And what is this value sir? 1 divided by root ts sir. Now calculate h of t sir. How to calculate h of t? First calculate p of t plus capital Ts. How to get this one? Subtract ts from all the t values. 0 minus ts minus ts, ts minus 0. Amplitude will never change. and then calculate h of t. Means from here to here, what is the difference? Go for a time reversal operation. How to get the time reversal operation? Multiply all t values by negative sign. Minus ts will be plus ts, 0 with minus also 0. This is the h of. So p of t we have, h of t we have. Both are nothing but two rectangular pulses of equal width. Two rectangular pulses of equal width will be a, I am writing finally output. Convolution of two rectangular pulses of equal width is a trapezoidal pulse. Sorry, equal width is a triangular pulse whose lower limit equal to sum of the two lower limits. Upper limit is equal to sum of the two upper limits. In between, draw the triangular pulse. How to calculate this amplitude, sir? Of course, up to here, Ts. Who will get the slope? Slope is nothing but product of their amplitudes. 1 by root 2 Ts, 1 by root 2 Ts. Then it will be 1 by Ts. Slope is 1 by Ts. From where to where it is increasing? 0 to Ts. So in a Ts duration, it can increase Ts into 1 by Ts. That is nothing but 1. So output y of t, the graphical representation, options are not given. This is the answer. Simple convolution of two rectangular pulses of equal width. The logic is here, you need to know the impulse response and basic time operations. This is given in the 2016 GATE examination for 1 mark. Clear? Yeah. See the next problem. The bit error probability of a memoryless binary symmetric channel is 10 power minus 5. If 10 power 5 bits are sent over the channel, then the probability that not more than one bit error, not more than one bit will be in error is a common model of problem only. But here he is asking the exact value. And if we see here, what is the probability of being error? The probability of error is here also the probability of error being success, which is 10 power minus 5. Then probability of errorless will be the failure, which is 1 minus 10 power minus 5. Follow. And what is asking? The probability 10 power 5 bits are transmitted, okay? The probability of error not more than 1 bit. Not more than 1 bit means the error may be 0 whole power 0, 1 minus 10 power minus 5 whole power 10 power 5 minus 0. The error may be 0 or not more than means the error may be 1 also. 1 means in out of 10 power 5, 1 into 10 power minus 5 whole power 1. 1 minus 10 power minus 5 whole power 10 power 5 minus 1. Just like here in place of n, 10 power 5 is there. What is this value? Any C 0 will be 1. Anything power 0 is 1. So 1 minus 10 power minus 5 whole power 10 power 5. And what is this value? NC1, n, that is 10 power 5 into 10 power minus 5 into 1 minus 10 power minus 5 whole power 10 power 5 minus 1. Just calculate by using calculator. 0.7357 will come. So you need to type here 0.7357. A common model of question only. In the previously they given n, 8, 3 like that. But here given 10 power 5 bits are transmitted. And he is asking about the error probability only. So error will be our success, remaining will be the failure. Just binomial theorem only. Clear? See the next problem. In a digital communication system, the overall pulse shape P of t at the receiver before the sampler has the Fourier transform P of f. If the symbols are transmitted at a rate of 2000 symbols per second. For which of the following cases is the inter-symbol interference is 0? ISI will be 0. He given 4 options. Say option A, B, C, D. First calculate how much is the bandwidth will come. The bandwidth is nothing but RB by 2 into 1 plus alpha. Any roll-off factor given? No. What is the rate given? 2000. 2000 by 2, 1000. So take the signals which is having bandwidth up to 1000. Now if you see the option A, 1.2 directly. Option B, there are some possibilities are there, wait. Option C also 1.2K. Option D also 1.2K. But in the option B, if you take the main lobe only, 0.8K means 800, less than 1000. So this is the possible options. Apart from that, nothing is in the problem. This is 17 gate examination, simple 1 mark question. See the problem. Which one of the following statement is true about DPCM? Option A, the sum of message signal sample with its production is quantized. Option B, the message signal sample is directly quantized with its production is not used. The difference of message signal and random signal is quantized. Option D, the difference of message signal sample with its production is quantized. What we are doing in differential PCM? In differential PCM, we are quantizing the difference between present sample, that is actual message sample, with a predicted sample. So the first time the question came on the differential PCM, that to the basic point on that. Simple 1 mark in the 17 gate exam. What we are quantizing? The difference between the sample and the predicted sample value. What we are doing in delta modulation? Present sample minus previous sample. That difference we are quantizing. Here the difference of message sample and predicted sample. Clear? Yeah. See the next problem. In a binary FSK, shift keying means binary frequency shift keying. The given signal waveforms are U0 of t equal to 5 cos 20,000 pi t. U1 of t equal to 5 cos 22,000 pi t. Both are of a duration t, where t is the bit duration. Bit duration in the interval and t is in second. Bit duration interval. Both U0 of t and U1 of t are 0 outside the interval 0 to t. With a matched filter based receiver, the smallest positive value of capital T in millisecond required to have U0 of t and U1 of t are uncorrelated. Option A 0.25 millisecond, option B 0.5 millisecond, option C 0.75 millisecond, option D 1.0 millisecond. Different organizations are given different answer. Let's listen my answer. My answer is different. My option is different. Of course, is asking in the 17 gate for 2 marks. What they are saying, sir? Uncorrelated, sir. What is the condition, sir? When you can say signals are uncorrelated, there is no correlation. The signals are, see here, the signals are orthogonal, sir. If the signals are orthogonal, those are uncorrelated. What is the condition? We already know for orthogonality, the F1 and F2 must be multiple integers of 1 by t or tb, or you can say rb, where n1 and 2 should be integers. He given 4 options. Take first option 1 by 0.25. 1 by 0.25 means 4 kilo. Multiply 4 kilo with some integer, f1 has to come, another integer f2 has to come. If you see what is f1 value, he given 10,000 means 10k. This is 11,000 means 11k. If we multiply 4 with some integer, 10 will come, 11 will come, No, leave it. Next, 0.5, 2 kilo. Multiply 2 kilo with some integer, 10. S will come. 2 5s are 10. But 11 will come? No, it should be integers. Leave it. Third option also in a similar manner. Fourth option, C, 1 milli, 1 kilo. 1 kilo multiply with some integer, 10 will come, 11 will come. So my answer is 1 millisecond. Option D is the correct one. Clear? He is giving uncorrelated. When uncorrelated, when those are orthogonal, simple orthogonality condition only applied. The same problem he given in a different model. In the previously we already seen. See the next problem. It is a simple question asking on the PCM. A sinusoidal message signal is converted to a PCM signal using a uniform quantizer. The required SQNR at the output of a quantizer is 40 dB. The minimum number of bits per sample needed to achieve the desired SQNR. A given sinusoidal signal, what is the signal to noise ratio or quantization noise ratio in decibels is 1.8 plus 6. This should be desired value required at the output of a quantizer is 40 dB. Then 6n equal to 40 minus 1.8. So 38.2. Then n will be 38.2 by 6. Generally n is an integer or accurate value. Anything if you do, no problem. Minimum number of bits is asking means, so at least it should be 7. So 7 you can type, no problem. That is the answer. Simple. Asking in a 17 gate for 1 mark. See the next problem. One of the good problem. A random variable x takes values minus 0.5 and plus 0.5 with the probabilities 1 by 4 and 1 by 4 and 3 by 4 respectively. The noisy observation of x is y equal to x plus z, where z is a uniform PDF over the interval minus 1 to 1. X and z are independent. If the MAP based detector output x cap is as x cap equal to minus 0.5 if y less than alpha plus 0.5 y greater than or equal to alpha, then the value of alpha means alpha is a decision threshold or optimum decision threshold. Now, first let me write what is f of z. F of z is a uniform PDF from minus 1 to plus 1. Obviously, this is 1 byte. What about the PDF of this minus 0.5? You can treat this as a x0, this as x1. Then it comes from minus 1.5 to plus 0.5. Same 1 by 2. What about the PDF for x1? Anyhow, optimal receiver will follow the MAP rule. We already know that, or I will write. This is from where to where? Plus 0.5 na? So, minus 0.5 to 1.5. This is also 1 by 2. What is the MAP rule? The output y received when you transmit x0 and the probability of x0 is greater than y by x1 if you received x1. If this is greater, transmitted is x1, x0. If less, transmitted is x1. That is the MAP rule. That is the MAP rule. Are you getting my point or not? So if this condition obeyed, that is nothing but the MAP rule. Now, if you see, definitely we seen in the previous problem also, where is the threshold lies for the optimum threshold lies. Optimum threshold means to get the minimum bit error rate. Then optimum threshold error will be lies at minus 0.5. So that alpha value should be minus 0.5. So you need to type minus 0.5 here. Got my point? A simple question asking in the 18 gate examination for 2 marks. 18 gate for 2. See the next problem. A binary source generates symbols x belongs to -1, 1, which are transmitted over a noisy channel. The probability of transmitting x equal to 1 is 0.5. Obviously, -1 also 0.5. Equiprobable. The input to the threshold detector is R equal to x plus n, means signal plus noise. The noise PDF, the PDF of Fn of a noise is shown below. If the detection threshold is 0, then the probability of error. Here probability of error, average probability of error, both will be same because both are equiprobable. Means I can say probability of error means PE0 plus PE1 divided by 2. So draw their corresponding PDFs. You can treat the first one is like x0 symbol. This is x1 symbol. Rather than 0, 1, they given -1 and a +1. So what is the PDF for 0? 0 means n by x0 you can feel. What is this PDF? Or you can feel R by x0, that's a better. Noise is also added. R by x0. So that will be shifted to -1 is the mean. So -3 and this will be 1. And this value is obviously 0.5. This is 1 by 0.25, that is 1 by 4. Obviously this is -2. Now write the PDF for x1, where for the x1 you can see 1, so its mean is 1. So it's shifted to 1. This will be 3. This is -1. This will be 0.5. Calculate the probability of 0 and probability of error for 0 and 1. The given threshold is 0. Then what is PE0? Probability of error for 0 is nothing but the probability of input greater than threshold. Greater means from threshold. Threshold is given 0. Up to maximum it is existed up to 1. So 0 to 1, what is its expression? A line going through expression of a line. Coming to the expression of line, it is a decreasing one. Now slope will be negative and this value is 1 by 0.5 means 1 by 4. So 0 to 1 decreasing. Change in y by change in x. Change in y is 1 by 4. Change in x is 1. But minus into you can take dr. So what is this value? -1 by 4. And 1 minus 0 will be 1. Got my point? Now, what is the probability of error for 1? Input is less than threshold. Means from -infinity you need to go, but it is from -1. Threshold is 0. What is this expression? Expression of this one is, this is say 1 by 4. Just like, one second, we missed one more thing. It's not going through origin. Y equal to mx. X means here that r, y equal to mx plus c. C means y intercept. Where it is crossing the y axis, that is at 1 by 4. Y equal to mx plus c into dr. We will calculate the value. Just a second. So this is -1 by 4. Integration of r will be r squared by 2. Limits are 1 to 0. So substitute the upper limit. So 1 by 2 minus 0, 1 by 2 plus 1 by 4 r. R means 1 minus 0, that is 1. So this will be -1 by 8 plus 1 by 4. So I can say this is nothing but 2 by 8, 1 by 8. So another 1 by 8 remaining. Because probability cannot be negative. Simple logic. This is -1 to 0. What is the expression of this line? 1 by 4 r plus 1 by 4 because crossing y-axis sector 1 by 4 into dr. So 1 by 4 r square by 2, 0 by 2 will be 0 minus 1 square by 2. So minus 1 by 2 plus 1 by 4 dr will be r, 0 minus of minus plus. So plus 1 will come. Here also you will get another 1 by 8. 1 by 8 will be gone. So 1 by 8 plus 1 by 8 students, 1 by 4. 1 by 4 by 2, 1 by 8. 1 by 8 plus 1 by 8, 2 by 8 means 1 by 4. 1 by 4 by 2, 1 by 8. Got the logic or not? Now, 1 by 8 means, what is the answer? 0.125. A simple problem only. Here both are equiprobable means the probability of error will be average probability of error. Both will be same. Are you getting my point? So that's I taken. By taking the PDFs of them, I calculated the value. See the next problem. A single bit equally like to be 0 and 1 is to be sent across an additive white Gaussian IC channel with PSD and not byte. Binary signaling with 0 as P of t and 1 as Q of t is used for transmission along with optimal receiver that minimizes the bit error probability. Let phi1 and phi2 form an orthogonal set if we choose P of t equal to phi1 of t, Q of t equal to minus phi1 of t. We would attain a certain bit error probability B suffix B. If we keep P of t is phi1 but take Q of t is root 2 phi2 of t, for what value of root E, this is root E phi2 of t. For what value of E would be attain the bit error probability PB, means same probability as the previous case. In the first case, draw the constellation. Phi1 and phi2 are the orthogonal base. Where is the P of t at a distance of 1 on phi1 side? Somewhere here, its distance is 1. Nothing is mentioned is 1. This is minus side. It is also a distance of 1. This is P of t. This is Q of t. And what is the distance here? D12 value is 2. Probability of error is P. Draw the second constellation. In the second constellation, he is saying that same phi1, phi2. What is the P of t value? Same phi1 of t. Means at a distance of 1. What is the second one? Root E phi2. Means somewhere here. This is root E. Root E. That will be the Q of t. And he is saying that both will have a same probability of error. Because second case also PB given. When same probability of error, here distance should be equal. Apply the Pythagoras theorem. Root of 1 square plus root E square. Are you getting me? Square on both sides. 4 equal to 1 plus E. So E value will be 3. 3 means option B is the correct one. Simple, they given for 2 marks. Just they given a lots of theory. Just by this equation, draw the constellation diagram. Same probability of error means equate the distance. Distance means the shortest distance only. See the next problem. A Y signal M of t is in the frequency range 5 to 15 kHz. The signal is amplitude modulated to generate an AM signal f of t equal to A into 1 plus M of t cos 2 pi FCT, where FC is 600 kilo. An AM signal f of t is to be designed and achieved. This is done by first sampling at 1.2 times Nyquist rate and then quantizing each sample using a 256 level quantizer. Finally, each quantized sample is binary coded using k bits, where k is the minimum number of bits required for encoding. The rate in Mbps of the resulting stream of a coded bits in megabits per second is. Here, actually this problem based on the band pass sampling, but what is there in the professor mind, we don't know. But he solved this problem by using normal sampling theory, normal sampling only. According to that only answer is given. Sir, why we are not doing band sampling means you can ask the professor who given this question. I got my point. Here, anyhow, what is the highest frequency will come, sir? First I am calculating the sampling rate, which is nothing but 1.2 times the Nyquist rate. That is 1.2 into 2 times the highest in AM. What is the highest frequency? Upper sideband FC plus FM. What is the highest value will come? 15 kilos. So 615. Because FC value is 600, FC plus FM highest. Upper sideband will be from 605 to 615. Highest component take 1.476 mega you will get. He is asking bit rate now, or rate, bit rate or data rate. What is the formula? RB equal to NFS. What is the N value? 256 level na? So N value is 8. And what is the sampling rate? 1.476 m. So 11.808 will come. So 11.81 megabits per second. So in the option you need to type 11.81 megabits per second. That is only he given answer. You got my point. Another thing is actually if any all modulated signals I told band pass signal, by doing band pass sampling, what is the answer is coming is not given in the key of IIT. So we need to go like this only. Nothing is in this problem, calculation of RB, NFS, FS value taking only. See the next problem. A random variable x takes values -1 and 1 with the probabilities 0.2 and 0.8 respectively. It is transmitted across a channel which adds noise n, so that the random variable at the channel output is y equal to x plus n. The noise n is independent of x and is uniformly distributed over the interval -2 to +2, uniform distribution. Receiver makes decision x cap -1 if y is less than or equal to theta, and +1 if y greater than theta. It's wrong written. Greater than theta, where theta belongs to -1 to +1 is chosen so as to minimize the probability of error. Here x cap not belongs to x. The minimum probability of error round off to 1 decimal place is probability of error is asking. Anyhow, minimum probability of error is asking. If we clearly see there, what is that noise is a noise PDF. I will write here for a spacing problem. Noise is uniformly distributed from -2 to 2. Obviously, this is 1/4. Then can you write the PDF of the y for -1 and +1? I am writing here. Try to concentrate. Fy for -1 transmission. Then this will be shifted to where? -3. Because mean value is -1. So -3 to +1. Obviously, somewhere here is the -1 point. Of course, 1/4. What about the PDF of a +1? That is Fy of y by +1. That is from where its mean value is 1. So obviously that is from, I am writing with the red colored one. This will be 3. Of course, this is also 1/4. Obviously, where is the error? There are two logics are there you can calculate. Obviously, minimum threshold will be between -1 to +1. He already mentioned. You will get the minimum error. Optimum threshold in between -1 to 1. You will get a minimum probability of error. Obviously, we see number of problems at the -1. How to calculate the probability of error or bit error rate? We know bit error rate is probability of 0 into probability of error for 0 plus probability of 1 into probability of error for 1. What's the probability of 0? Of course, in place of 0, he given -1 and +1. So -1 take 0.2 into probability of error for 0 means here -1 plus this is 0.8 into probability of error for 1. Common formulas you can apply. Are you getting my point? See. Now, that is one logic. How to calculate this one? When our input is greater than this. When our input is greater, because -1 has to come. If it is greater, +1 will come. So error. When for this one less than the threshold, means here theta. Common thing we done, number of problems. Another logic also there. Simply probability of error means this shaded region also you can calculate. Are you understand my point or not? That shaded region also you can calculate. Now here, as usual our common formula if you apply 0.2 into what is the probability of error for -1? Whenever input is greater than that, greater than the threshold. Threshold is -1 to infinity, but this is existing up to +1. What is this value? 1/4 into dr plus 0.8 into when the probability of error for 1, when our input is less than that, less than means minus infinity, but it's existing from -1 up to threshold, threshold also at -1 means obviously this value will come as a 0. So 1/4, 0.2 into 1/4, dr means r, 1 minus of minus, so 2. So 2, then it will be 0.1. Any ways you can solve the problem. Even 2 into that also, if you shade region also if you take, the same manner will come. So 0.1 is the minimum probability of error. See the next problem. This is asking in the 20 gate for 1 mark. The regular model only with a slight twist. A digital communication system transmits a block of n bits. The probability of error in decoding a bit is alpha. Probability of error is alpha. What's the probability of errorless? It should be 1 minus alpha. Whether it is a success or failure, I will write. And what is the probability of error? Is alpha. The error of each bit is independent of the error events of the other bits. The received block is declared as erroneous if at least one of its bits decoded is wrongly. Erroneous meaning means wrong. Error mean. The meaning is error. The probability that the received block is erroneous is, he given options are n into 1 minus alpha, option B alpha power n, option C 1 minus alpha power n, option D 1 minus alpha whole power n. Try to understand. When it is treating as a erroneous means wrongly. When it is treating as at least one. At least one means 1 or 2 or 3 or 4 or 5, anything. When it will be errorless? It will be errorless if it is 0. First I will calculate for errorless. Then 1 minus errorless will be the erroneous probability. Are you getting my point? So here errorless will be our success. This will be the failure. I will calculate for errorless. When errorless, they all are correct. So NC0, 1 minus alpha whole power 0, alpha whole power n minus 0. So n. Then what is this value? NC0 is 1. This is 1. So alpha power n. This is for errorless. So erroneous, then one minus errorless, 1 minus alpha power n. Then it is option C. A slight tricky question, simple they given for 1 mark. Clear?